Okay, buckle up. It's going to be fast. I'm going to show you 4 proofs. What I want you to pay attention to especially is the last line in each of these proofs. Okay, proof number 1. We've got 4 angles here formed by 2 intersecting lines. What I want to get to is to prove that angle 1 is congruent to angle 3. In other words, prove that the vertical angles are congruent. We know that angle 1 plus angle 2 makes 180 degrees. We also know that angle 2 plus angle 3 makes 180 degrees. And the reason why we know that is because 1 and 2 form a straight line. We also know that 2 and 3 also form a straight line, and their line formation intersects at angle 2. That's important. The reason why this is 180 degrees as a total is because linear angles make 180 degrees or a straight line. You could also use the word supplementary or say something about a semicircle there. We're going to bring these 2 lines together because we know that 1 and 2 is worth 180. What else is worth 180 is 2 and 3. So we can replace this 180 with the 2 and the 3. That's called substitution when you make that replacement. So angle 1 plus angle 2 is equal to angle 2 plus angle 3. We substituted to get there. Substitution. And now we're noticing that in order to prove that angle 1 is congruent to angle 3, there's really only one obstacle in our way, and that's angle 2. Luckily for us, angle 2 is on both sides, so we can just subtract it away. So the reason why this is true is because of subtraction. Now, some students on this question will say that the reason why angle 1 is congruent to angle 3, they'll write instead vertical angles are equal. Now, it is true that vertical angles are equal, but we can't use what we're trying to prove. In other words, we have to say how we arrived from the lines above to get to our final line right here. It wasn't vertical angles that got us there. It was a move of subtraction that got us to our final answer. You're going to see the same sort of temptation show up on all of these proofs. So let's look at the next one. In this picture right here, I've got 2 parallel lines cut by a transversal, and I'm trying to prove that angle 1 and angle 2 are equal. And I'm going to use angle 3 to help me prove that they're equal. So the goal is to prove that the alternate interior angles are always congruent. Prove angle 1 is congruent to angle 2. Stick with me. See how this all makes sense to you. So we know that angle 1 must be the same as angle 3 because those are called corresponding angles, and those have to be equal if the lines are parallel. So we can count on that angle 1 is the same as angle 3. We also know that angle 3 must be the same as angle 2 because those are called vertical angles. In the last proof, we were not allowed to use the fact that vertical angles are congruent. But we can here because we're not trying to prove that they're congruent, so we can use that as a tool to help us prove other things. So this is very similar to the last one because what we're at saying that 1 is equal to 3, and we know that 3 is equal to 2. So we can replace the 3 with angle number 2. So the 3 is getting tired, it's getting substituted out. Who can go in for 3 is 2. So again, this has a substitution step in it, and that's the end of the proof. We'd say that angle 1 must be the same as angle 3, as angle 2. So we've reached the end of our proof, and the reason why it's true is not alternate interior angles are equal. That is, these are alternate interior angles, and it's true that they are equal, but that's not how we proved it. We proved it by substituting to arrive at the answer. Okay, proof number 3. Okay, in this proof right here, I'm trying to prove that angle 1, 2, and 3 make 180 degrees. In other words, prove that the three angles of a triangle add up to 180 degrees. These proofs are pretty fast, so you can always pause it and replay it if you have to. So in order to get there, usually they'll give you an extra line right off the bat that's parallel to one side of the triangle. And if they're really nice on these questions, sometimes they actually fill in some missing numbers there to help you use those angles that are on the outside of that triangle to help you with the proof. Here's how it works. First thing we can say is angle 1 is equal to angle 4. And we can also say that angle 2 must be equal or congruent to angle 5. So in the picture, those yellow angles, 1 and 4, are the same. And also, these blue angles, 2 and 5, are the same. And the reason why that is true is because alternate interior angles are equal. And it's the same reason for both of those two lines. Now we're allowed to use that now because we have actually proved that those are equal to each other in the last proof that we just did. So we're allowed to use pieces of other proofs that we've used before. So what we need to do to get the idea of 180 going into the proof is we need to write something about angles making 180 degrees. And those angles there at the top, 3, 4, and 5, all add up to make 180 degrees. Angle 4 plus angle 3 plus angle 5, all total 180 degrees. Those three angles are linear. The goal is to prove 1, 2, and 3 make 180. So that's where we want to get is angle 1 plus angle 2 plus angle 3 equals 180. And you can see that we're kind of close. We've got the 180s matching up. We've got the 3s matching up. We just need a way to get rid of this 4 and to get rid of this 5. And the way that gets us to the final line is to do a replacement again. We can replace angle 4 with angle number 1. Above it says that angle 5 can be replaced by angle number 2. If we make those substitutions, we get to the final line of the proof. So substitution is the way to finish this proof off. Did you get tempted to think that it's something else? Many students will say, or some students will say, oh, the three angles of a triangle add up to 180 degrees. And their reason next to it will be a triangle has 180 degrees. And that is wrong to use that fact at this time. Timing is everything. And right now, it's not the reason that the triangle has 180 degrees that got us from the line above to the last line of the proof. It was a substitution move that got us there. Okay, the final proof has got something with the angles. And on the exterior angle proof, we're trying to prove that angles 1 and 2 add up to make angle 4. This is called the exterior angle theorem. And in this proof, I'm going to work it out backwards. We're trying to prove that angle 1 plus angle 2 equals angle 4. So in my proof, I want to talk about angle 1. What do I know about something about angle 1 that's in the picture? Well, there's not much going on over there. It looks like an acute angle. I know that if I take angle 1 along with angle 2 and I take that with angle 3, that together I can get 180 degrees. So if there's anything that I wanted to, if there's anything I can talk about with angle number 1, it's that together with 2 and 3, they make 180 degrees. Then that gets my work started here. A triangle has 180 degrees. We're using a fact from the last proof. Okay, Can I say something is true? Now, look, I've already talked about angle 1 and angle 2. That's pretty good. Now I need to talk something about angle 4 in the next line. Well, I know that 4 and 3 together make 180 degrees. That's a rule. That's one of our facts, is that a line has 180 degrees. You could say linear angles or supplementary, or you could say a half a circle is 180 degrees. So our proof so far has facts about angles 1, 2, and 4, which is good. The thing to notice is that there's 180 that shows up in both of those statements. So substitution would be something that you could actually use to finish this proof off. The 180 here can get replaced by 3 and 4. So think about that 180 disappearing, and in its place, 3 and 4 jump in to take its place. It's going to be a pretty long line here. Angle 1 plus angle 2 plus angle 3 must be the same as angle 3 plus angle 4. So to get us there, it was substitution. And then noticing that angle 3 is on both sides of the equal sign. And our final line, there is no angle 3. If we wiped away the angle 3, all we would be left with would be what our target was. So in order to get to this last line, it's subtraction that helps us lift away those angle 3's. And that wraps things up for these 4 proofs. 4 important proofs. I went through them fast. Replay them a few times if you have to. Make sure you try to commit those to memory about how they go. And hopefully this did give you another chance to replay in your mind some of the moves we did in class. So be prepared, and good luck studying.